Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over Bronsted-Lowry acids and bases, conjugate acids and bases. And so we're going to go over a few examples in this video. So we have 4 examples. We'll go over the first one, A. Here you have H2SO4, sulfuric acid, reacting with water to form HSO4 minus and your hydronium ion. And so in this sort of problem, they're asking you, okay, identify the conjugate acid and base. So the thing you need to remember is that when we're talking about the acid and the base, we're only talking about what is as a reactant. So we're not referring to these as acids or bases. We're going to be referring to these or as an acid or a base according to the Bronsted-Lowry definition. And remember, the Bronsted-Lowry definition of an acid and a base is whether or not it accepts or donates a proton or an H+ ion. So if it's a donor, if it's a proton donor or H+ ion donor, then it's an acid. If it's a proton acceptor or an H+ ion acceptor, then it is a base, and that's the definition. So when you're labeling the acid and base, you've got to label the reactants as acids or bases. When you're talking about conjugate acid or base, that's going to be the resulting products. And the conjugate acid comes from the base, and the conjugate base comes from the acid. And so those are what we call the acid-base pairs, or conjugate acid-base pairs. So if we start here, which one is giving off the proton? Which one is donating a proton? And so what you see here is H2SO4 is losing a hydrogen. So if this is losing hydrogen, then this is the acid. So if I use a different color marker, so then this would be labeled at, ooh, that's not good. Let's try this one. So this would be the acid. And so the water here is accepting the proton, accepting the H+. So that would be, so the water would be the base in this example. So it's accepting the proton. So this is the base. Now when we're looking for the conjugate acid and base, the conjugate acid and base would be the complementary part of this, the complementary product that comes from the acid or base. So here we have the acid. When the acid gives away its high H+, you get HSO4 minus. So here, this is the result of giving away its hydrogen. So this would be the conjugate base. So here, here we have the conjugate base. Okay, so this is the acid, so then this is the conjugate base, because this could theoretically pick up the hydrogen again and go back this way, although it is a one-directional reaction since this is a strong acid. So this is, we will label this the conjugate base of the acid. So conjugate base. And then the base, water picks up a hydrogen, but then this hydronium could give off the hydrogen again. So this is a base. This could give away its proton, and then that way it would be a base. So it's a conjugate base in this regard. So this would be the conjugate base. So the acid, whatever forms from the acid is the conjugate base. Whatever forms from the base is the conjugate acid. Excuse me. All right, what about the next one? So here we have CH3O minus, or O3 minus, and that's going to react with water. And here we have in equilibrium. So this can go, this is reversible, so it can go back and forth. So here again, we're looking at what the proton acceptor and proton donors are. So here we're going to label acids and bases. The products that form are going to be labeled conjugate acids and bases. And the conjugate acid comes from the base, and the conjugate base comes from the acid. So here, what we notice here, HCO3 minus becomes H2CO3. So it's gaining hydrogen, and it looks like it's coming from the water. So this here is the base because it's accepting a proton. And the water here is giving off the proton. It loses a proton and becomes OH. So it's losing the H plus on it. So this is going to be the acid. So you're giving away your H plus. And so again, the base becomes the acid. So this is the conjugate acid. So conjugate acid. And again, you can go backwards. So if you go back, then this acid loses the proton and becomes HCO3 minus. So that's why it's called the conjugate acid. So these two are related to it. The only difference between these two is a hydrogen. The only difference between these two is a hydrogen. The only difference between these two is a hydrogen. So this is the acid. So therefore, this is the conjugate base. Is the hydroxide ion. Okay. So in this case, water is acting as a base. In this case, water is acting as an acid, and so that's what we call amphoteric. Okay. So here again, in this example, we have C5H5N reacting with water to give you C5H5NH plus and OH minus. So this is acting as a base because it's picking up a hydrogen. So this would be the base. And that means that water is acting as the acid. So if this is the base, then this is the conjugate acid. Conjugate acid. And if this is the acid, then this must be the conjugate base. Conjugate base. And the last one, here we have HNO3 and water. So HNO3 goes to NO3 minus. It loses the hydrogen, so that means that this is the acid. And this is the conjugate base coming from the acid, so this would be the conjugate base. And here water is picking up the hydrogen, so that's acting as a base. So it's picking up the hydrogen, so this is the base. And this is the conjugate acid. Because, again, you can go backwards. This is a reversible reaction, the double arrow. And so if you go backwards, the H3O plus, the hydronium ion, can lose that hydrogen, give off, or donate the proton back to NO3 minus to give you HNO3 and water. So that's why it's called the conjugate acid and base. That is how you can determine and identify who or what the conjugate acids and bases are, or what the acids and bases are. Again, you'll notice that only the acids and bases are only on the reactant side. Conjugate acids and bases are only on the product side. So you need to keep that straight. I hope this was helpful. If you like this video, like, share, subscribe, hit the notification bell. Thanks for joining me, and I'll see you next time.